Hello friends, this is Dr. Shana Mounty, Assistant Professor in Mathematics, Government First Grade College, Jeevargi. In this video, we are going to study about the Fourier series, which is a example of the what we can say that the odd and even function in the interval minus L comma L, 0 comma 2L, 0 comma 2 pi and minus pi comma pi. Before going to the example, first we should know the definition of even and odd function. A function f of x is defined over the interval minus L comma L is said to be even if if f of minus x is equal to x. For example, f of x is equal to cos x and f of x is equal to 2x square minus 3x to the power of 4. Here these examples, we already know that the cos is even function and another function which contains the power is even. So that means whatever the value of x, it is to be even only. In the other definition, that is the definition for odd function, it is defined in the interval minus L comma L is said to be odd function if f of x is equal to minus of f of x. For example, f of sin x and f of x is equal to 2x cube minus 3x to the power of 5. In the periodic function, we know that the all the value of x are real and it is a positive integer. In that case, f of x plus t is equal to f of x, where t is a period that we can define as 2 pi. So that the period 2 pi is called the periodic function. In that case, we can define the Fourier series in the interval c comma c plus 2l, and the expression is f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos n pi x divided by l plus summation n is equal to 1 to infinity b n sin n pi x divided by l. In this series, we know the a naught, an and bn are the Fourier coefficients of the Euler's formula, and we can define it as a naught is equal to 1 divided by L integral c to c plus 2L f of x dx. An is equal to 1 divided by L integral c to c plus 2L f of x dx into cos n pi x divided by L, and bn is equal to 1 divided by L integral c to c plus 2L f of x sin n pi x divided by L into dx. And for these Fourier series with the Fourier coefficient, according to the even and odd function, we can say that the problems which contains what the coefficient terms. According to the even and odd function, the nature and the condition of the series is when the function is even, the series which contains only a naught and an. If the function is odd, the series, that is a Euler series, a Fourier series which contains only the bn value. According to the period L comma L minus L comma L 0 comma 2L and 0 comma 2 pi and minus pi comma pi. Using these conditions, we will go for the example. In this example, see the function f of x is pi minus x divided by 2 in 0 less than or equal to x less than or equal to 2 pi, and hence deducing the value, that is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dash dash is equal to pi divided by 4. The solution of the function, that is f of x is equal to pi minus x divided by 2. Here f is 2 2 pi minus x, that is equal to minus f of x. Hence the function is odd. Therefore, a0 is equal to 0, an is equal to 0. Because already we know that if the function is odd, then we can say that the Fourier series contains only one Euler number, that is Bn. Therefore, the Bn is equal to 2 divided by pi integral 0 to pi f of x sin n pi x into dx, because this is an example for the interval 0 comma 2 pi. So that is Bn is equal to 2 divided by pi of integral 0 to 2 pi minus x divided by x sin n x into dx. And rewriting using the integral by parts rules, that is 2 divided by pi, the first function x minus pi into integral of the sin nx is minus cos nx divided by n, which is running from 0 to pi, and the second differentiation of the first term, that is x minus pi is equal to minus 1 into the integral of the integral term, that is minus, as it is cos nx value is sin nx divided by n, and already n is there, so it is minus sin nx divided by n square, which is also running from 0 to pi. On substituting the value of the upper limit and lower limit and cancelling all the terms, we will get Pn is equal to 1 divided by n. Therefore, the Fourier expansion of the function is given by f of x is equal to summation n is equal to 1 to infinity Bn sin nx. According to the earlier, we already solved the Bn value is equal to 1 divided by n, and the f of x is equal to pi minus x divided by 2. And substituting these values in the expansion, we will get it is as pi minus x divided by 2 summation n is equal to 1 to infinity 1 divided by n sin nx. Put x is equal to pi divided by 2, then the expansion becomes pi divided by 4 is equal to 1 divided by 1 minus 1 divided by 2 plus 1 divided by 3 minus dash dash. This will you know already how to expand, how to analyze the summation values. In the another example, see f of x which is equal to x into 2 pi minus x in the interval 0 comma 2 pi. F of x is equal to x into 2 pi minus x, and that is equal to f of x, because the function is even. Therefore, if the function is even, already we know that the Fourier expansion which contains a0 and an. So for that, the Fourier series expansion is looks like f of x is equal to a0 divided by 2 plus summation n is equal to 1 to infinity an cos nx. In this series, there are two unknowns, that is a0 and an. Using the Euler's expansion function, we can define a0 is equal to 2 divided by L integral 0 to pi f of x dx, and solving the a0 value, that is f of x is equal to x into 2 pi minus x. So that is a0 is equal to 2 divided by L integral 0 to pi 2 pi x minus x square into dx. On expansion or using the integral, the a0 will is equal to, on integration we will get a0 is equal to pi square divided by 3, because we you know already that is integration of 2 pi x is 2 pi x square divided by 2, and the integral of x square is x cube divided by 3. Substituting the upper and lower limit and solving the series, we will get it is a0 is equal to pi square divided by 3. And another unknown value, that is an, and that is defined as 2 divided by pi integral 0 to pi x into pi x minus x cos nx into dx. Multiplying the bracket term, it is 2 pi x minus x square cos nx into dx. Here the integral term contains the product of two terms. So using the Bernoulli rule, we can solve the above an value by using the Bernoulli rule, which is keeping the first function and taking the integral of the second, minus integration differentiation of the first term and integration of the second term, and applying the lower and upper limit, we will get an is equal to minus 4 divided by n square. After solving the a0 and an values, the series is equal to 2 pi square by 3 minus summation n is equal to 1 to infinity 4 divided by n square cos nx. On expansion, we can solve the other things, otherwise keep it as it is. For that also you will get the marks. In the other case, that is the interval which is in the form of minus pi to pi. In that case, the function f of x is defined as according to the interval, that is minus pi greater than x less than 0. So that is x is in between minus pi and 0. The function is minus x. If the x values lies in between 0 to pi, then the f of x value is 0. According to this, the series expansion, how we can rewrite as f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx. This function is neither odd nor even. Therefore, we need to find the coefficient a0, an and bn. Why it is neither need not be odd and even function means because the interval is in between minus pi and pi. So that in that case we can doesn't say that it is even and odd. So the coefficient terms a0 is defined as 1 divided by pi integral minus pi to pi f of x into dx, and the other a0 is equal to 1 divided by pi minus pi to 0 f of x dx plus 1 divided by pi integral 0 to pi f of x dx, because the main interval is minus pi to pi, and that minus pi to pi we can divide in the two intervals, that is minus pi to 0 and 0 to pi. Using that, the function f of x is minus x dx, and the another interval f of x defined as equal to 0. So that on integrating the values, integral of x is x square divided by 2, and which is running from minus pi to 0. Applying the upper limit and lower limit, the a0 value is minus pi divided by 2. In the same manner, the an value is equal to 1 divided by pi, the integral minus pi to pi f of x cos n pi x divided by x. In the same, splitting the interval and expanding the terms, we will get an is equal to 1 minus of minus 1 to the power of n divided by pi n square. In similar way, the bn value is equal to 1 divided by pi, the integral minus pi to pi f of x sin n pi x into dx. And in the same, using the Bernoulli and dividing the interval and taking the integration of the terms and applying the lower and upper limit, we will get the bn value is minus 1 to the power of n divided by n. And these are the some references that I used to solving the examples. Thank you.